fellow Earthlings! Welcome to the new adventure of Earth Scientific Journey. I am Teacher Dobes, your Earth Science enthusiast. Today we will explore another mystery of science, the captivating journey on absolute dating. So buckle up, dear explorers, as we set forth to unravel the mysteries that surround us on this extraordinary scientific adventure. After going through this lesson, you are expected to do the following. Identify the methods of determining the age of stratified rocks. Distinguish the difference between absolute dating and relative dating. And apply the methods in determining the age of rocks. Before we proceed with our lesson, answer the following questions. Which of the following statements is true regarding the cost and time involved in absolute dating techniques? A. Absolute dating is inexpensive and quick. B. Absolute dating is expensive and time-consuming. C. The cost and time required depend on the type of rock. Or letter D. Absolute dating is always quicker than relative dating. What do you think is the correct answer? Very good. Letter B. Absolute dating is expensive and time-consuming. Question number 2. After 4 half-lives have elapsed, how many parent isotopes will remain in the sample? A. 16 parent isotopes. B. 4 parent isotopes. C. 8 parent isotopes. Or letter D. 1 parent isotope. What is your answer? Excellent. It's letter D. 1 parent isotope. Question number 3. One way of determining the age of rock is based on radioactive dating. Which of the following describes radioactive dating? A. It determines the age of the sample by measuring the amount of a particular radioactive isotope present in the sample. B. A particular form of a living being may have been defined a protein content in their bodies that deteriorates with time. C. The number of annual growth rings of a dicot is used in this technique to determine the age of the tree. Or letter D. The technique that determines the final period during which the object absorbs light emitting electrons. Do you think you got this right this time? What is your answer? Very good, it's letter A. It determines the age of sample by measuring the amount of particular radioactive isotope present in the sample. You are an archaeologist working on a dig site and want to determine the age of an organic artifact, such as a piece of wood or bone. Which radiometric dating method should you employ? A. Rubidium-strontium dating. B. Uranium-lead dating. C. Potassium-argon dating. Or letter D. Carbon-14 dating. Good job! The correct answer is letter D. Carbon-14 dating. Question number 5. Why is potassium-argon dating particularly effective for dating volcanic rocks and minerals? A. Volcanic rocks contain more potassium-40. B. Argon gas is not trapped in volcanic minerals. C. Argon gas can be trapped in minerals as they solidify. Or letter D. Volcanic rocks have a unique crystal structure.
is your answer? Well done. It's letter C. Argon gas can be trapped in minerals as they solidify.
Today, we're going on a little adventure, and it all starts right here at my favorite store. I just spotted this cool magazine about a K-pop group that I want to read. The only problem, I cannot remember the group's name. But not to worry, I'll figure it out when I get home. However, there's another twist in our story today. We'll also explore how geologists determine the ages of rocks, which might sound a bit strange right now, but trust me, it's fascinating. Alright, I'm back home, and I've got my stack of magazines right here. Let's see what I've got. We've got magazines from March, February, and finally January. They're all mixed up now, but fortunately for us, there's a simple way to organize them. You see, magazine dates are printed on the cover, making it easy to stock them in order. So let's start with the oldest one, the January edition. We'll place it at the bottom of the stock. Then comes February. And on top of that, we'll place the March edition. Voila! Our magazines are now neatly stacked, with the oldest at the bottom and the newest at the top. But you know what's interesting? Rocks don't have dates stamped on them. Or do they? Well, that's where the world of geology comes in. Let's put aside these magazines for a moment and delve into the fascinating world of rock dating. One of the most powerful tools in their toolkit is radiometric or absolute dating. This technique relies on the natural decay of radioactive isotopes within rocks. By measuring the ratio of parent isotopes to daughter isotopes, geologists can calculate the age of rock with remarkable precision. So, let's talk about isotopes. Atoms of the same element that have the same number of protons but different numbers of neutrons are called isotopes. Most isotopes are stable, but some are not. These unstable isotopes are what we call radioactive. When a radioactive isotope breaks down into a stable isotope of the same element or another element, we call it radioactive decay. The unstable isotope is known as the parent isotope, while the stable one produced by decay is called the daughter isotope. Now, let's talk about half-life. The half-life of an isotope is the time it takes for half of radioactive sample to decay. It's a critical concept in radiometric dating. As time passes, the amount of parent material decreases by 1/2 after each half-life. For example, after one half-life, half of the parent material has turned into daughter materials. After 4 half-lives, only one parent isotope remains. So, how do scientists use these principles to date objects? Well, it depends on the age of the sample. Let's explore 4 radiometric dating methods. Uranium-lead dating. This method involves the decay of uranium-238 into lead-206 and uranium-235 into lead-207. It is used for dating minerals found in igneous rocks. Potassium-argon dating. Potassium-40 decays into argon-40. This method is perfect for dating volcanic rocks and minerals. Rubidium-strontium dating. Rubidium-87 decays into strontium-87. It's primarily used for dating older rocks associated with continental crust. Carbon-14 dating. Carbon-14 is produced in the atmosphere and decays into nitrogen-14. It's ideal for dating organic materials up to about 50,000 years old. Did you know that in a cave in the Philippines, researchers made a remarkable discovery of fossil bones and teeth? These remains appear to come from a new human-like species. Scientists have just dubbed its species Homo luzonensis. They took the name from Luzon, the island on which the fossil's remains were found. To date how the old fossils were, scientists analyzed the radioactive decay of uranium in one tooth. This suggested the bones are at least 50,000 years old. These 5 fossil teeth, dug up in the Philippines, all came from one individual. Their distinct mix of traits led researchers to declare the species that left them a new human-like relative. Absolute dating often requires time and effort to obtain accurate results. This value teaches patience and dedication in the pursuit of knowledge. In the Philippines, it can serve as a reminder that understanding and preserving the country's history is an ongoing process that requires perseverance. In summary, radiometric dating is a powerful tool that allows scientists to determine the ages of objects by measuring the decay of isotopes. The choice of dating methods depends on the age of the sample and the isotope used. It's a fascinating world of science that unveils the secrets of our planet's history. We have just covered some important information in today's lesson. Now, it's time to assess your understanding of this topic by answering the comprehension questions.
What is the primary isotope used in uranium-lead dating for determining the age of rocks and minerals? A. Carbon-14, B. Uranium-238, C. Potassium-40, or letter D. Strontium-87. What do you think is the correct answer? Perfect! It's letter B. Uranium-238. Question number 2. You are investigating the age of minerals in a metamorphic rock sample. Which radiometric dating method is well suited for this task? A. Carbon-14 dating, B. Uranium-lead dating, C. Potassium-argon dating, or letter D. Rubidium-strontium dating. What is your answer? Well done! You nailed it! The correct answer is letter D. Rubidium-strontium dating. Question number 3. You are an archaeologist working on a dig site and want to determine the age of an organic artifact such as a piece of wood or bone. Which radiometric dating method should you employ? A. Rubidium-strontium dating, B. Uranium-lead dating, C. Potassium-argon dating, or letter D. Carbon-14 dating. What is your answer? Very good. It's letter D. Carbon-14 dating. Question number 4. You are dating a mineral sample using rubidium-strontium dating and find that the age calculated is 500 million years. What do you infer about the age of the minerals? A. The minerals are 500 million years old. B. The minerals are 4.5 billion years old. C. The minerals are younger than 500,000 years. Or letter D. The minerals cannot be accurately dated with rubidium-strontium dating. Do you think you get this right this time? What is your answer? Very good, it's letter A. The minerals are 500 million years old. Question number 5. A geologist discovers a layer of volcanic ash in a rock formation. How can radiometric dating be used to determine the age of this layer? A. Measure the thickness of the layer. B. Count the number of fossils in the layer. C. Analyze the radioactive isotopes in the ash. D. Estimate the layer's age based on its color. What is your answer from this question? You got it right, it's letter C. Analyze the radioactive isotopes in the ash.
Thank you for participating in our scientific adventure. Join us again for another exciting exploration. I am Teacher Delves, your Earth Science enthusiast, saying, unlocking the mystery of our past, one radioactive decay at a time. Keep exploring, keep learning, and until next time, stay curious, see you, and goodbye.